Good morning, boys and girls. I want to welcome you to another chemistry class. And please, I need to say this quickly. There are some of us that are not serious with what we are doing. And I will start to remove you very soon. So your parents have paid and you need to do what is needful. Please, we need to wake up. Today we want to look at just a topic that we will use to conclude all we've been talking about for some weeks on acids, bases, and salts. We want to look at the pH of some substances. And then we look at indicators, and then that will be it for acid, bases, and salt. So let's look at the pH values of some substances. As you can see on the slide, we have some substances and their corresponding pH values. You can see some of them, they have very low pH values, and some they have high pH values. As we've discussed earlier, you know what the pH value means. pH is the negative logarithm of the hydrogen ion concentration. This we have done before. So just look at the slide and check the particular substance with its own value. Now, if you look at the table carefully, what can we get from the table? Those substances with pH values ranging from 0.0 to 6.9, they are acidic in nature. I believe we know that already. E.g., lemon, banana, tomatoes, they are acidic. You know pH 7 is neutral. That is neither acidic nor basic. And a very good example is water. Water has a pH value of 7. Then a pH that is above 7, then between 7.1 to 14.0, you know is basic. So those substances with such pH values are basic substances. For example, the seawater, the blood plasma, and as you can see on the slide. So you know when you are taking a substance, you will know whether what you are taking is acidic or basic in nature. Now, what are the importance of pH? What is the importance? Now, we should look at some of these importance. Acidic medium is required for digestion of food in the stomach. And that is why God even made hydrochloric acid to be part of the solutions in the stomach. Without that acidic medium, digestion may not take place in the stomach. Also, when you go to the small intestine, alkaline medium is required. So you should understand all of this. Then the human blood is about 7.4. That's the pH of the blood. And a little deviation from this may be very dangerous. And that's why injections are buffered to prevent any change in pH values, because it's a very sensitive issue. Don't forget that pH has to do with the level of concentration of hydrogen ion, and it can be vital to human health. Then, most plants grow well in soils with pH of 7.0 to 8.0, near neutral. No, 7 is neutral, so a little between neutral and alkaline. That is 8.0. So acidic soils must be treated so that they will not affect the growth of some plants. And that's why we use slake lime, a base, to neutralize acidic soil. For example, now maybe a particular farmland is close to the industry where chemicals like SO2 is given off. So when there is rain will react with the SO2 to form acid, and that can make the particular soil acidic, which will not be very good for planting. So we need to neutralize it. Then pharmacy, medicine, water purification, sewage treatment also make use of pH value in their operations. So we need to know all of this. Then let's quickly look at indicators. What are indicators? Indicators are weak organic acids or bases that will produce different colors in solutions depending on the hydrogen ion concentration in that solution. As you all know, litmus paper. When you put litmus paper in an acidic solution, it turns from blue to red. And if you put that same litmus paper in a basic solution, it turns from red to blue. So indicators will change color depending on the medium where you put them. Now, since they are weak acids or bases, they ionize partially or slightly in solution. So they ionize partially or slightly. That's why they are able to switch between a particular color to another color. Now, just like we have said, indicators are substances that will help us to know the dominating substance in a solution. Solutions always contain two substances. We have acidic and basic substances. And through the color shown by the indicator, we know if the solution has more of acidic substance or more of basic substances, or maybe they are dominating equally. So when you put indicator in a solution, depending on which is more, the indicator will show with the color that it will display. Now let's look at some common indicators. We have methyl orange. Maybe when school resumes, we will be able to go to the lab and you see some of these things. Methyl orange in an acidic medium will turn to pink, while in a basic medium, it will turn to yellow. So that means if you put methyl orange in hydrochloric acid, for example, the color you will see will be pink. And if you put that same methyl orange in a substance like sodium hydroxide, the color you will see will be yellow. So you will be able to know, if you don't know the solution before, with the aid of methyl orange, you will know either the solution is acidic or it's a basic solution. Then litmus paper, that one we are very familiar with litmus paper. For litmus paper, you know the color in acidic is red. We are very used to that. And in a basic medium, the color is blue. We are very used to that. Then we have phenolphthalein. In acidic solution, it will be colorless, while in basic solution, it will be purple. That's phenolphthalein. Then we have methyl red. In acidic medium, it is red, and while in basic medium, it is yellow. Then we have the universal indicator, which can be red, pink, or yellow in acidic medium, but in a basic medium, it is dark green, blue, or violet in a basic medium. Now, in an acid-base indicators, there are dyes which change color according to the pH of the medium. That's a summary of what we have been talking about. So during titration, titrating an acid with a base, in a neutralization reaction, we use indicators to determine the endpoint. What do we mean by the endpoint? The endpoint is the exact point where the acid is completely neutralized by the base. So that means at that point, the solution is neutral, is neither acidic nor neutral. So that will be shown by the indicator. We can see in the next slide typical titrations and the choice of indicator that can be used. So as you can see, your WA means weak acid, your WB weak base, strong acid is SA and strong base is SB. So in a titration reaction, we are talking about mixing an acid with a base. So when you are mixing a strong acid against a strong base, for example, HCl and NaOH, strong acid and a strong base, we can use any indicator because the two solutions are strong. Any of the indicators, either methyl orange, phenolphthalein, methyl red, can be used. And then the change in pH will be between 3.5 to 9.5 because the two are strong solutions. Then if we are titrating a weak acid against a strong base, for example, ethanoic acid is a weak acid versus a strong base, sodium hydroxide. Please don't mind the error in that place. Ethanoic acid versus sodium hydroxide, we can use phenolphthalein. That's the suitable indicator to use. Then if we are titrating a strong acid against a weak base, strong acid against a weak base, for example, hydrochloric acid versus aqueous ammonia. Hydrochloric acid is a strong acid, aqueous ammonia is a weak base. Then we use methyl orange for that. Methyl orange for that. And the range of pH change is between 3.5 and 7.0. That of the weak acid and strong base is 7.0 to 9.5. Let's take note of that. Then if you are titrating a weak acid against a weak base, the two of them are weak. For example, we have the same ethanoic acid versus aqueous ammonia. For this, there is no suitable indicator. No suitable indicator can be used. So we don't normally titrate a weak acid versus a weak base. Now let's look at uses of indicators. As we have just explained, they are used in acid-base titration to determine the endpoint. Then they are also used to show pathways of chemical reactions. Because of the color, you will know where a particular reaction has reached, and you will know the medium of that particular reaction. Then there are also universal indicators can be used to determine the extent of acidity and alkalinity of a substance. As I believe by the time you go over what I've explained, you will understand more and more. This will conclude all we need to know under acids, bases, and salt. So in our next class, we'll be going to a new topic entirely. Thanks for listening. Your classwork/assignment will be posted. Please make sure you copy this note down, then do your classwork and submit as at when due. God bless you.